All right, 8th graders, lesson 71%, change of dimensions. We've done a little bit of this where if I would take a smaller triangle, make it into a larger one. We talk about that being a dilation when we start talking about transformations. And many machines like copiers can take a little image and we can blow it up on the computer. We can make it 200% bigger if we wanted to do that. So dilation always has to do with you take 100% of the original size and then add another percent. We're also going to deal with making things smaller, and that's going to be called a reduction. And there again we start with 100%, the original size, and then we subtract a certain percent to make it the smaller amount. Okay, so we're increasing and decreasing. The biggest concept to try to understand here, so I'll try to use a square to help us out here, and I'm going to draw a little. So we're going to take this little square here and we're going to use a dilation. We want to increase it. So if I have all of this square, what percent do I have? Correct, I have 100%. I have all of this square. So if I wanted to take this and increase it to this size, how many of these squares fit in here? Well, in this case, I have 1, 2, 3, 4 of them. So I've taken my original 100% and I've increased it 300%. So what's my total increase? It's a 400% increase. You have to include that first 100%, the original size, plus whatever percentage it is that you're growing by. That's a pretty big scale. We could show that on a little. If we take that same thing, and maybe we only want to increase it by 20%. Okay, there I've divided it into fifths, so that little piece right there would be 20%. So if I added on that much more, my paper is now, I still have the original size, so I have the original size 100% and I've added 20% more, so now I have 120% of my original size. Same thing with reducing. If we take away one of these, I would take away 20%. Alright, let's take a look at example 1. One square is 50% larger than another square. The perimeter of the larger square is what percent of the perimeter of the smaller square? A. B, the area of the larger square is what percent of the area of the smaller square, and C, provide two examples that fit that description. So let's draw a square here. This is going to be our original one, and we're going to say my dimension of the side here is 1 inch, let's say. So if I were to increase that, make it 50% greater, then that would be like multiplying it by a half, and half of 1 is 1.5. So this side would now be 1.5 inches. So I've increased it by 150%. The original inch plus half of the original inch, which is half of an inch. So if I continue doing that all the way around, okay, I now have 1.5 inches all the way around. This is 1 inch over here. So the perimeter of the larger square is what percent of the perimeter of the smaller square? On the perimeter of the smaller square is 4, and the larger square is going to be 6. Okay, so the perimeter is 150% larger. Again, this is 100%, 4, and if I take that 4 and add the half of it to get up to 6, 2, that's 50%. So I've increased the perimeter by 150% by increasing the side. Now B is asking about the area. So let's see what we can do with the area. Here we have, let's change the color here, 1 times 1, so this will be 1 square inch. This over here, 1.5 times 1.5, so let's do that, 5 times 5, and you don't know, it'll be 222.5, so we get 2.25 square inches. So in this case, I've increased it. I've got my original size, so that's 100%. And then I've added 1, so if I take my original 1 square inch and I've added another 1.25 square inches. So I've added another 100% for this 1. And I've added another 25% over there. So in the end, the area is 225% larger than the smaller square. Okay? So it's a lot of math that I'm showing here. As time goes on, this will come much more easily and naturally to you. Okay? All right, and then C, provide 2 examples of the 2 squares that fit that description, and we've done that right here. I've made a model of that by giving some dimensions to it, because it's easier to work with dimensions than it is just to work with theory. So for C, we've already completed that. All right, example 2 here. The towel shrunk 10% when it was washed. The area of the towel was reduced by what percent? So the area was reduced by what percent, and then provide an example of before and after. Now, assuming that the towel shrunk uniformly, the length was reduced by 10% and the width was reduced by 10%. Since the length and the width are both 90% of the original size, the scale factor of the original size is 0.9. So we took the towel and we shrunk it by 10%. So we lopped off this piece over here. So that is 10%. But then we'd also lop off that piece over there, and that's more. These 2 pieces together are more than 10%. So what we do is we say 0.9, because we took off 10% each of them, we'd have 90%. But we've got to square that 0.9 times 0.9 to figure out what percent this part is that's left in here. And you know that 0.9 times 0.9 is going to equal 0.81. And if we convert that to a percent, we know that this is 81%. That means we have removed these 2 together will equal 19%. So we've taken off 19% of the original size. That's a reduction. And then provide an example of a before and after. So let's do that. Let's say this is a big one and this is a little bit smaller one. And we can give some dimensions. We can say this is 50 by 100. So this would now be 10%. This would be 45 by 90. If we take away 10% of each of those. And now if you figured out the area, you would see that the area of the second one is 81% of the original. So we could solve that there as well. But the main key here that we're looking at is we took 10% off this side and 10% off this side. So we took a total of, looks like about 20%, but not quite, because we had a little bit of a shared area here. So we took off just less than 20%. We took off 19. All right, example 3. The vertices of a square are 4, 4, and so we'll mark that here. All right, so here we see in example 3, we've marked all of those. Sketch a square in its image after 125% dilation. So we want to make a larger one, and then it says the perimeter of the dilation is what percent greater than the perimeter of the original square. So let's just take the number 4. 100% of 4 will be 4, and what is 25% of 4, or 1/4, will be a 1. So we're adding 4 plus 1. So basically everything will be all 5s now. So let's add that in here. 5, 5, 5, negative 5, 5. Put that down here, and down over here, and then we can connect all those. So this is our dilation by 125%. The perimeter is what percent greater? Now we should remember that from example 1. The perimeter is 120, so it'll be 25% larger. The perimeter, so before it was 8 and 8 and 8 and 8, so the perimeter with the blue one, P equaled 8 times 4 is 32. And with the larger one, the green one, the perimeter, there you now have 10 times 4, so that's 40. And so it's 25% larger. 1/4 of 32 is 8, so we add 8 to another 32, and that gives us 40. So it's 25% larger. And then they also want to know the area. The area is what percent greater than the area. So the area here of our first smaller one, we would have 8 times 8, so the area would equal 64 units squared. And in the green one, we now have 10 times 10, so the area would equal 100 units squared. And now we want to know how much of an increase is that. And to figure out that increase, we would have to divide the areas of those units to figure that out. Alright, so let's keep going there with example 3. So we had the area of the larger one was 100 square units, and the area of the smaller one was 64. 100 divided by 64, that'll be 1.5625. So it's 156.25% larger, but we want to know just the increase, and that would be 56.25% increase. So the area is 56% larger, the new area. We've added 56.25%. So if we go back to the out one, we have the two squares. What we're looking at is we're looking at the area that's in between the two. We've added in this area 56.25% more area. Alright, let's take a look at the last example here, example 4. If the dimensions of a cube are increased by 100%, what is percent is the volume increased? So if I've got a little cube here, and I say it's 1 centimeter, and then I've got another cube over here, and it's 2 centimeters. What percent did I increase it? The volume. Well, the volume of this one is 1 square cubic centimeter. Over here in this one, I have 2 times 2 times 2, so that will be 8 cubic centimeters. So it's increased by 800%. Now here's the tricky part. They're not asking what is the total percentage of the first one, but they're asking by how much has it increased. So 800 minus the original, this is, we'd say, is 100%. That's the original size. So 700% is the amount that it increased, because we take away the little bits of that first 100%. So the increase is by 700%. So a little bit tricky knowing which one are they going to be asking for. They're asking for how much greater did it increase. Usually that will be the total percentage. When they're asking for how much did it increase, or the volume increase, the size increase, then we usually take away the 100%. Like we did in the last one, and it was only 50%. That the area that we added was 56% more. That's it for today. You can get started on your lesson practice, 8th graders.